coming from sunny London. Unfortunately, Steve and Adele still had a bit of sun glazing in my face. That has gone now in the last 5 minutes. We good to go, Adele? Excellent. Welcome, everybody. Thanks for joining us. We're excited to have you. It's a second edition of our tech series, which is our monthly thought leadership event. And I'm Ulrika. I'm looking after marketing here at eSynergy. And for those of you who are not familiar with us, we're just quickly, I'll keep it brief. We're a technology consultancy delivering business value from the cloud. We do that predominantly in 3 areas. That's cloud adoption. So everything here from readiness assessments to migration to optimization and scale. The second one is around cloud native software development. And the third service offering we have is data engineering. And I guess where eSynergy differs from a lot of the traditional consultancies, well, some of them that haven't been bought yet, at least, is that we have a business model that works with contractors. So we're leveraging the gig economy quite strongly, where we have a network of around 250 fully vetted, very senior and experienced technologists that we can tap in and out of depending on the skill set, on the experience, and on the industry sector vertical that our clients face business and technology problems. We focus as a business on 2 industry verticals, one of them being financial services, and the second one is the public sector. About tonight, so we're joined by Steve Wade, who led our project with Mettle, which is NatWest's challenger bank. And today he'll tell us a little bit about the project, the challenges we were facing, the solutions we built, and some of the value add we could deliver. Steve is a senior platform engineer currently at UnderwriteMe, but he has held a ton of very senior technology positions across the public and the private sector. Not enough from me yet, a bit of housekeeping. We have enough time for Q&A after Steve's talk, and we'll have to take the questions in the chat box. So at the bottom of your screen, where it says chat, whether you want to put in the questions throughout the talk or at the end, we'll go to that after the talk. And then secondly, we are recording this session just as FY. Steve.
Over to me.
Over to you.
I think you need to stop sharing. Cool. Firstly, can everyone see my screen? Okay, we're on to a good start. So I'm here today to talk to you about how we built a self-service platform at Mettle, taking them from the platform that I kind of inherited on day 1 of joining, and then in 2.5 years, what we produced as an engineering team. And I've obviously moved on now, so we can talk a little bit more about the roadmap of features and functionality that they're looking to implement in the future. So my name is Steve Wade, like Ulrika has already mentioned, senior platform engineer at UnderwriteMe. So I've left my previous role at Mettle, so this is kind of a historical talk. I'm not completely up to date with exactly what they're doing. I have a kind of rough idea. I left about 6 months ago. I've left all my contact information, so this is going to be somewhat of a high-level talk. We're not going to go into a ton of detail, but if you want to go into a ton of detail, please feel free to reach out to me on any one of those links below. I'm more than happy to have some conversations. So I want to start with this quote by Kelsey in 2019. So he said, "Once you've found success, your next goal should be helping others to do the same." And I've kind of replaced that a little bit with a pattern that works. So at Mettle, we found a pattern that really worked, that scaled for the number of developers that we had and enabled innovation within the product teams without the platform team and the platform getting in the way. So in the next half an hour, I'm essentially going to take you on this journey from where we started and to where I kind of rolled off after 2.5 years of this implementation. What you'll notice here is that I didn't put the number of tweets, retweets and likes, because Kelsey trumps mine by about 1,900, and it's just a little bit embarrassing. So the agenda for tonight, I want to focus and start with the business problem. I think that's the most important thing to start with. The technology is the interesting bit, but if it doesn't solve a business problem, then what's the point? A little bit of a history lesson talking about what we're going to call Platform V1, or the platform that was there on the day that I joined. The journey thus far, so where are we at now? Looking back at the challenges that we faced, some of them are going to become obvious as this slide deck goes on. Some of them maybe not so obvious. And then there is a lot of moving parts, and there's a lot of technology that is going to be on display. And some of you may never have heard of it. Some of you may just be starting to look at it because it's the next new buzzword that everyone's, every bit of marketing in the technology space is currently using. So how can you get started on this journey? And then finally, as Erika said, we'll close out with a Q&A. So let's start with the business problem. So what is Mettle, and why did Mettle come around? So essentially, its role was to get a license to be able to build a bank. So Mettle is a venture inside of NatWest, and it was essentially spun up to implement business banking for small to medium large enterprises, all the way from kind of contractors to handymen to companies that have 5, 10, 15, 20 employees, and to provide them business banking that is completely digital. So there's no branches, there's no bricks and mortar. You can't go into a Mettle bank and ask them to send you, submit a check. It's all done via an application, via your handset. So you can send invoices, you can chase invoices, send receipts, money inbound and outbound. So the reason why I feel that Mettle was started was to show NatWest a new way of doing things. So they are obviously a very large organization that has a lot of red tape, and I think that's in the large majority of all enterprises. There is some red tape there. So how could we remove the red tape, innovate at speed, saving money, so making it more cost friendly? So we always used to talk about at Mettle cost per customer. So how cheaply can we run the platform or the platforms to be able to service our customers, and how does that scale over time? And then essentially a stronger proposition for those small business customers to come and bank with Mettle. So I think the important thing is to always start at the beginning. So let's kind of roll the clock back. Now we're talking 3 years to what I and the platform team called Platform V1. So this is me day one rolling in to the Mettle office in Angel. And this picture is actually very apt, and we're going to come onto this shortly, of this kind of 2 dogs that are tugging at a little bit of rope. So to start with, it was very ticket driven. And what do I mean by that? So single platform engineer looking after the platform. At this point in time in Mettle's journey, they were right at the beginning. So they were at a phase of the project called Mince Pie. It was aptly named Mince Pie because we took the project sponsor downstairs and we bought her a mince pie, and we showed her on a mobile phone, you have just bought a mince pie and it costs £6. Yes, we're in central London. A mince pie does cost £6. So there was a very small team. They had a lot of engineers that were working on functionality and trying to deliver features to a very small set at that point of customers. And at that time, there was a single platform engineer. So the platform engineer was obviously swamped by developers' feature requests. Can you add me a new S3 bucket? I need to be able to onboard my application. Can you add me a new database, et cetera, et cetera. And as any developer knows, that a platform engineer's backlog is more important than yours. So we're obviously not going to do your features that you want. We've got our own features that we need to be working on. So it was very commonplace at that time for developers to come around and say, where's my S3 bucket? And I'd be like, what do you mean, where's your S3 bucket? And I was like, they were like, well, I put it on your Jira board. And I was like, oh, well, our Jira board's quite long. We've got a long backlog. We haven't got to it. Oh, well, I posted it there like 2 weeks ago. So I now can't ship my feature because I've been waiting for you for 2 weeks. So there's this, you can start to see now this tug of war between developers wanting to innovate and the platform team not being able to move fast enough. And when we get to scale, we have more customers, we have more product teams that are delivering more features. This is going to really start to become a blocker on innovation. It was ClickOps. So what do I mean by that? Really, the infrastructure in the platform wasn't really fully automated. It was in parts and it wasn't in others. And by ClickOps, I mean, we literally go to the console and add a security group rule to allow port 80 outbound, or to add a load balancer. It got to the stage where we actually had to ask Amazon if we could create more load balancers, because it was getting in such a spaghetti state that what ended up happening was that dev and staging looks nothing like production. So any confidence that you got in dev and staging, you essentially didn't really have any by the time you got to production, because they were so vastly different. And the platform team would work with the development team or the developers at the time, help them, onboard their new microservice to, I don't know, ship bills to customers. We'd get that all nicely working with a couple of load balancers, a couple of S3 buckets, whatever they needed in dev and staging. By the time that got to production, it was a completely different setup. So they had no confidence. So what this led to is really slow release cycles. So I'm talking like weeks to deliver a feature. And by feature, I mean, it could be something really small. It could be adding the customer's address to an invoice, something very basic like that. But because there was all this, there were all these stumbling blocks and hurdles in the way to be able to deliver that feature to the customers, everything was very slow. There was this constant kind of tug of war between development and operations. So if you're on the development side, it's always, it's a platform problem. It's not working because of the platform. We've seen this hundreds of times before. We really need to fix the platform. And if you're on the platform side, it's, well, you guys currently max me 20-1, so I can't do 20 people's jobs. I'm just a small team trying to get through this as fast as we possibly can. So because what I've been talking about, it makes changes very risky. So we're running in finance. We're providing essentially a banking service to our customers, and our changes are risky. This is not a great position to be in, right? It's not a great position to be in at all. And then you add on the fact that we're now dealing with customers' money and chasing potential invoices for their customers. This is not a great look and feel for anybody. And then production changes were even more riskier. And yeah, this picture is kind of a little bit like what I was at the beginning. I was always nervous about someone shipping something to production because I had very little or limited confidence in what was going on dev and staging that would replicate that nicely to production. Then this was me going in front of senior members of the board or product leads, explaining to them the reasons why their production release had failed or their product team can't ship their features, right? So this is a very glum face, and he's struggling to try and come up with an answer. And myself being a professional, I knew this wasn't the position that we wanted to be in, right? I got bought in to be able to provide them a platform that scaled and allowed them to be able to innovate. And right now, we're not implementing either of those two things. So we have unhappy business people and unhappy developers. That makes a very unhappy platform team, right? And essentially, what we needed to do is completely turn the frown upside down and make sure that everybody was happy and everybody could get on with their jobs. And if we did that, we've succeeded in our implementation. This was a big problem. So confidence is contagious, and so is the lack of confidence. Everybody was having a lack of confidence in our team. Business people, developers, testers, security team, right? And even to some degree, the larger bank had their microscope out because they were looking at this new venture that essentially didn't have any of the red tape. So we really needed to fix this. We had to stop this from happening, right? We had to stop this tug of war between developers and the platform team. We're one big team that's working on a common goal to deliver functionality and features to our customers to allow them to be able to do their jobs. We've all got to become one big team, none of this tug of war. So that's enough of kind of the doom and gloom. How on earth did we actually get into a position whereby everybody is singing from the same hymn sheet and everybody is on the same page? So that was V1. Now we're going to talk about V2. So V2 out the gate was developed to be self-service to the product teams, right? We had to provide them self-service. We had to get away from us having a massive backlog of things that we needed to do for them. They should be empowered to add whatever they want to do to be able to deliver that piece of functionality, with a caveat of some guardrails to make sure they don't do anything stupid, like create a 64 terabyte database when they only mean to have 64 gigs. So we wanted it to be self-service, and hopefully I deliberately chose Sainsbury's here because they don't get insufficient item in bagging area. It's normally pretty reliable. So on any good kind of transformation, you really need a mission statement that you can stand behind when you implement. So our mission statement was this: to provide an easily extensible, so we needed it to be able to change because over the course of X number of years, the roadmap, the features and functionality could change that we need to implement. So we need it to be easily extensible. We want it to be config driven. So what do I mean by that? I don't mean ClickOps, I mean defined in code and executed, right? So we've got a number of reasons for doing that, which I'll come on to later. Ephemeral platforms. So we didn't want these long-lived platforms in development, staging, and production that had nodes that were running for hundreds and hundreds of days. That box over there, no one really wants to touch it because they're a little bit nervous about what it actually does and how it works. We didn't want that. We wanted this concept of these becoming throwaway, where when we start to talk about Kubernetes, it's all about your applications or your workloads are throwaway. They run for a period of time. The node may die. The workload will die and get respawned somewhere else. So we wanted to take that to the next level, where we're talking about now a whole entire platform to some degree that is completely throwaway. Obviously, there's some caveats there. We can't throw away the data because then we'll lose everybody's transactions and everybody's invoices, and we'll have 0 happy customers. Clear ownership, right? We needed to define these boundaries. We don't want a massive to-do list, but there are also things that the platform team own, and there's things that product teams own, and we had to work that through. There's some shared ownership models, and there's some very specific product team ownership models, and we'll kind of cover those shortly. And then most importantly, reliable and consistent, right? We can't keep covering our eyes every time we're doing a deployment to production. We need this to become a non-event. We want them to be shipping features to their customers all day, every day, without any interaction from the platform team. And the platform team's job is to enable them to be even more self-service and to provide them a rich feature set for the platform that they're leveraging. So let's start with easily extensible config driven. How did we attack and implement that first section there? So we run everything at this time on AWS, and we're going to use Kubernetes as our abstraction layer. And then on top of that, we're going to run our workloads, right? Pretty simple on the, at a 3,000 foot or 30,000 foot view. We need to get into the weeds a little bit on how we actually implemented this. So the first thing that we did is we defined the use of Terraform upfront from day one. And we were going to have a repository of modules. So think of modules as kind of an a la carte menu of pieces of infrastructure that you could deploy into your platform. So we could go as basic as an S3 bucket, or as complex as a whole Kubernetes cluster. And the reason why we wanted these as an a la carte menu is so the developers and the product teams can pick and choose the modules that they need to be able to deploy and run their applications or their microservices. And we have a number of dedicated Terraform routes. And what are routes? Think of routes as repositories that are executed in a specific order, but also have their own independent lifecycle. So think of things such as like a database. That's going to have a very different lifecycle and a very different upgrade cycle and edit cycle than something like potentially IAM roles. So IAM roles, our ability to be able to access our infrastructure. We're likely to be adding a lot more of those than we are tweaking a database. So we wanted to split these things out. So we had a number of routes that were executed in order to build the platform. And we used to call it the vanilla platform. So the platform without any workloads, essentially. And then we had routes that were specific to given product teams. So you may have TFM, data, and then product team. And that was their Terraform that they needed to be able to deploy the infrastructure that they required for their product. So we now had an extensible pattern whereby a new product team comes on, we provide them with a new repository, a nice templated repository so they don't have to think too much and we get the consistency. And then they leverage these a la carte modules and consume them to be able to leverage them within the platform. So here's just a very quick overview of Terraform modules. So as we said, it's a centralized location for all of our modules. And inside of these, you can see that we've got a number of different things. So we go all the way from an account in Amazon to the AMI or the Amazon machine image that we're actually going to use, all the way up to CloudTrail and a CloudTrail S3 bucket. So there were at the time of me leaving probably around 45 modules that were up for consumption. So here is a redacted view of what a production deployment of the Kubernetes route would be. So this would be TFN K8s, because this is standing up Kubernetes. So you can see at the top there, the key is K8s prod. So we had this 3-letter environment prefix for everything we were doing. And it has its own state. And then at the bottom there, we are consuming the Kubernetes module from our Terraform modules repository. And then we are passing in any values that we need to pass in at that point to be able to create the Kubernetes cluster. What you would have noticed, the eagle eye of you, is that there were modules that were specifically prefixed with the word application. And these ones were the ones that the development team are going to leverage, or the product teams, sorry. So the overall architecture of the Mettle platform was pretty consistent. You would potentially leverage an S3 bucket, potentially leverage a database, and then we kind of had Kafka as the central kind of data store in the middle. So in terms of infrastructure that was required for a given product, you were really looking at an IAM role and an S3 bucket and maybe a database. So we had these application-specific modules that allowed developers to be able to consume them and knew that they had the quote-unquote best practice implementation within those modules. So they didn't have to care about that. They just used those modules as an abstraction, understood what the variables were that they needed to pass in, and then pass those in, and then we have a secure S3 bucket and an IAM role for you to be able to access that bucket. Again, here, the ability for them to be able to consume those modules. So as you can see at the top section there where we've got app X bucket, a lot of those variables are already passed in because they are generic sets of variables that need to go to almost every module so that we get consistent naming, consistent tagging, etc., etc. So this is great. Well done. You've got a load of repositories. You've got a centralized modules repository. Congratulations. If you're a developer, you're thinking, well, that's a hell of a lot of code and I don't really understand it. So I can't possibly work out how I'm actually going to be able to leverage this. So we implemented Atlantis as a kind of centralized tool that all infrastructure was run through. So this is just taken from the Atlantis website. It's essentially Terraform execution by pull request. So you submit your PR, you get a number of approvers, you run a plan, the plan gets printed out, someone reviews that plan, they approve the changes, you type Atlantis apply, the Terraform code is executed in the background, and then you merge the pull request, or we actually had it so that the merge request was automatically merged on successful Terraform apply. So we're now driving all these changes through Git. So there's no one on laptops running Terraform apply. It's all done from a centralized location. So why did we do this? Well, this allows us to be able to scale out horizontally, right? We can have even more product teams that use Atlantis, and we can move engineers between product teams and they understand the way that they make changes from an infrastructure perspective. So we've got this extensible and config driven part now, but how do we get this clear ownership? We defined clear ownership by leveraging everybody's favorite buzzword if you're in the cloud native space, which is GitOps. So essentially GitOps looks a little bit like this. So the developers obviously hated the platform engineers, and the platform engineers looked at GitOps as a way out. And they needed to make this leap, because if they made this leap, we knew that we were going to have happy developers, right? We just had to get it in place. So for anyone that's used Kubernetes before, you're probably familiar with these types of commands. So this is applying YAML files or resources to kube. The second one is setting an image. So how do you upgrade from 1.1 to 1.2? Or leveraging a tool like Helm. So essentially what you do is you just replace all of that with a Git merge. So we're going to drive all of the changes inside Kubernetes now from pull requests. So we've done it with infrastructure. We now want to do it with Kubernetes as well. So to start with, we're going to leverage a tool called Flux. So Flux is an agent that sits inside the cluster. So everything here at the bottom right, which is in the kind of dashed box, is running inside Kubernetes. And then everything else is outside. So what you'll notice here in the bottom left is you can't run kubectl apply. We're going to come onto that later. That's a slight problem for some people. And there are two ways of being able to make changes to the cluster. One is by syncing changes from Git, or the other one is by syncing or looking for new images in your image registry that meet a specific prefix. So it's either a commit to Git or a push of a new container image. They're the only way that you're going to be able to get changes into the cluster. No more kubectl apply from people's laptops. No more kubectl apply from a kind of centralized CI tool that essentially has God mode in every one of our clusters. So Flux's kind of right-hand man or best friend in this whole implementation is something called the Helm Operator. So in Platform V1, the product teams were using Helm charts to be able to deploy their applications, but each product team had their own Helm charts. They're not Kubernetes experts, and nor should they be. However, what we all know about engineers is they love to copy and paste, and copying and pasting things that may or may not be correct. So there was a lot of inconsistency there. So one of the things that we did is we moved to a single backend chart. So all backend microservices were instantiated or deployed from a centralized backend chart that they then filled in to specify how they wanted their application to be deployed. And the Helm Operator is the centralized component. And what you deploy is a resource called a Helm release. And the Helm operator's job is to take that Helm release and do something with it. So either install it, upgrade it, delete it, roll it back. All of the things that you would normally do with the Helm command, the Helm operator is actually responsible for doing that now inside your cluster. So what does a Helm release look like? Well, here's a very kind of simplistic one, and it's really broken down into two sections. You'll see the chart at the bottom underneath spec there. You have a name of a chart, the repository that you're going to get it from, and the version of the chart that you want to leverage. And then a values section where you put all of the values that you want for your Helm release. So there's obviously going to be some default values in the Helm chart. These are essentially overrides for you to be able to override that for your platform. And we were talking about the fact that we could sync changes based on uploading new images. So there's two annotations in Flux, the two there in yellow. Automated true means for this Helm release, we're going to allow automated image upgrades. And then the semantic version there on the second line is the semvar that Flux is going to look at to make a decision of whether or not it wants to upgrade it. So if Cert Manager released a 13.1 release, Flux would automatically pick it up on its next sync cycle, deploy the changes, and write those back to Git with a Git commit saying, I've just upgraded Cert Manager from 13.0 to 13.1. Pretty powerful mechanism. We're going to kind of come back to why that's really powerful for us a little bit later. Want to kind of touch a little bit, on secrets. Secrets is a little bit of an interesting topic when it comes to Kubernetes. So at Mettle, we leveraged, and they still leverage, I think today, sealed secrets. So essentially how this works is you have a public key that is in your repository, a private key which is in your cluster, and you encrypt your secret, you commit it to Git, and the only thing that has the ability to decrypt it is the sealed secrets controller within your environment. So all of our secrets were committed to Git. We had a Flux that was responsible for syncing them, and then sealed secrets kind of did the magic and presented them to our product teams as normal Kubernetes secrets. So that's great. We've got a little bit of an idea now of how we could possibly leverage this, but how do we actually do it in, for real? So there was two main repositories. There's K8's releases platform, and these are all of the workloads and manifests that we need as a platform team to provide the product teams with a platform that we are happy with. So this is everything from role-based access control to make sure that they only get read-only in the platform, all the way up to the Helm release that deployed Prometheus and Grafana for us to be able to get good observability into the cluster and kind of everything in between. The main one that I want to touch on today is K8's releases Mettle. This is the workloads that are deployed to provide our customers Mettle as a product, a complete product end to end. So they have a customized directory. For anyone that doesn't really know how customized works, essentially you have a base and then you have patches, and those patches are overrides. So the reason for that is we don't want to repeat ourselves for every single environment that we add. We want to have a lot of configuration in one place and have a environments directory, which is simply just the diff or the environment specific configuration. So let me kind of come on to what that looks like. So here is our non-environment specific version of an app X Helm release. So you'll see at the top there, we've got a name of app X in our example namespace. We're leveraging our backend chart there, and we have a couple of values, right? So every application we are going to deploy in every environment with a replica count of 3, and we are going to use this, this random image here. So this is in the base directory. If you look at the bottom down here, it says customize base. Then if we switch to dev, so now we're in the customized dev directory, you'll start to see that there's a couple of things that have changed. So we've added this filter now where we're going to start to look for new images, and it's dev-star because we're in the dev platform. So you can probably imagine what UAT and production is going to look like, right? It's very consistent. The chart version is specified at this level because the chart version is tightly coupled to the Kubernetes version. So we're going to upgrade Kubernetes one by one. And for any of you who know Kubernetes, you know they love to create breaking changes. So when we upgraded from 1.14 to 1.16, and 1.16 is where they deprecated a load of APIs, we used this version as a way of knowing that the Helm releases that we were about to merge to master were ready for a 1.16 platform. And the way we did that is we changed that first one to a 2, and everything that was a 2 was ready for the 1.16 clusters. So it's just a way of us being able to get a better handle on those breaking changes. And then again, at the bottom, the tag that we're going to leverage is dev dash, and then we had a commit SHA. Then all we did is copied and pasted this for every single microservice in every single environment. So think that dev dash star, we replaced it with UAT dash star or production dash star. So now we've got this consistent pattern for everybody to be able to deploy to any environment. They need to understand the Helm release. They understand this pattern of if you're in the dev environment, you need the dev prefix. If you're in the production environment, you need the production prefix. So how do we actually deploy these changes through the environments? So the developers used and still use today Concourse. And the key decision that we made is that we embedded GitOps into the way they work. We didn't replace the way they worked with GitOps, right? If we replace the way they worked with GitOps, there's going to be this tension again. They spent a lot of time writing a lot of pipelines to perform all their testing. We wanted to hook in just at the right time to take over the deployment piece of the puzzle and leave them with everything else. So they would perform a Docker build, and they build it at dev dash the commit SHA, because the commit is the thing that's unique. They would then push this to our image registry. Flux is sitting inside the dev cluster, looking for new images, patches our Helm release that we have, applies essentially a kubectl apply-f to the Kubernetes cluster, and then finally commits that back to Git, stating that we have deployed the application. We've upgraded it. At the same time, because we have this back-end chart now, and we have such a consistent labeling taxonomy for everything that we deploy, we wrote a very generic wait script. And what that wait script does is waits for the rollout to complete, because we know the tag that we're looking for and we know the name of the application. So we can write a very generic read-only kubectl command that allows them to be able to understand whether their deployment was successful or not. After they've done that, they perform the testing. That's the thing that is in their domain. They understand how to test their application. They know when they are confident to deploy that release to the next environment. To deploy that release to the next environment, they re-tag the image with the next environment and the same commit SHA. And it's essentially rinse and repeat, right? It's the same process for them to deploy to any environment. So what you can see here is we've now got this cookie cutter environment, or this cookie cutter pipeline, for them to be able to deploy any application that they want to any Kubernetes platform in a consistent fashion. Simples, right? Okay, smart ass. So you've talked about how you deploy applications, but how do you actually make Kubernetes-based changes? So it's ever so slightly different here. We leverage Circle CI. We don't need Concourse. We don't need something that kind of penetrates and looks at our clusters. So the first thing we do is we run a set of deprecation checks, and we leverage a tool called CompTest. And what this does is make sure that all of our YAML files, because you can imagine with Kubernetes, there are YAML files absolutely everywhere, Helm charts, Helm releases, etc. We want to make sure that we're not using deprecated APIs. So we were testing against a 120 release of Kubernetes when we were still on 116. So we knew that we could go from 116 to 120 with confidence that from an API perspective, we were not going to hit any problems. This wasn't the case when we went from 114 to 116. So we actually wrote this tool to do that, that migration. Then we execute kubeval. So what kubeval does is strict linting against the upstream JSON schema. So we were running Kubernetes 116 that has their own JSON schema. So we would run kubeval in strict mode to make sure that we weren't adding anything to our deployment or our service that shouldn't be there. And if it was there, we would fail. So all we're doing here is we're giving ourselves more confidence that by the time the thing that we are deploying gets to the cluster, it's going to work, right? It's going to deploy and Kubernetes is going to be happy with it. And then the final one is HRVal. And what HRVal stands for is Helm Release Validation. So if you remember back a couple of slides, the thing that we were validating or the thing that we are deploying is the Helm release. We're not deploying a Helm chart, we're deploying a Helm release. So what HRVal does is takes your Helm release, gets the chart that you've specified at the version that you've set, templates that with the values that you've set in your Helm release, and then runs conf test for deprecation checks and kubeval against that. Because that is the thing that you're actually deploying. All of this Helm chart stuff is not really what you're deploying. You want to get confidence in the actual manifest that is getting deployed to Kubernetes and what is happening when the Helm operator picks it up. So these are kind of the three sets of checks that we run against every repository from a Kubernetes standpoint. So we've got the clear ownership now. We've got these repositories that different teams are responsible for. How do we keep things reliable and consistent? So this is kind of where the magic really happens and of how the cluster actually gets bootstrapped. And if you remember, I was talking about this 3-character environment prefix. So dev, UAT, stage, production. That flows through everything that we do, right? Is paramount to that. So again, we stand up the infrastructure using Terraform, we deploy Kubernetes, and then the first thing that gets deployed is a Flux instance that points at KH Release's platform. That's going to give us our vanilla platform. When we deploy that Flux instance via Terraform, we have to point it at a directory. So we are pointing it at the master branch, at the dev directory, and we sync it back to a dev tag. So that gives us a directory with inside that repository for development, and it is going to sync that repository, and then the cluster bootstrapping is going to start to happen. So in our Terraform code, one of the things we passed in, if you remember, is the environment name, and the environment name in this instance is dev, and then everything else flows from that. So once KH Release's platform, the platform Flux comes up, we deploy a Flux for KH Release's Mettle, for the Mettle workloads, another one for KH secrets, for the secrets, another one for Kafka topics, right? It's getting a bit laborious now. You probably get where I'm going with this. Same thing with network policies, another one for Istio resources, and they were all pointing at some directory in that repository / the environment prefix. So now we have a one command execution to stand up a whole entire platform and reconcile everything from Git and be fully synced. So if we exclude the data from this, we can now throw away the development environment or the development cluster, rebuild it from scratch, let all this reconciliation happen, and we are back to the position that we were in 25, 30 minutes ago before we destroyed it. So this whole process takes around 25 minutes to kind of fully reconcile everything. So that's great, right? You've got this, this really good implementation. You've got a nice way of being able to deploy workloads. But what are some of the difficulties, right? It wasn't all roses and chocolates. So I think Heather Downing puts it best when she says technology is easy, but people are hard, right? It was the people part of the puzzle that was really the biggest challenge for us. So if you remember before, I was saying you can't do kubectl apply. So when you go and tell the developers that every time they used to be able to access Kubernetes, they used to be able to deploy things with kubectl apply, and everyone, because developers love to copy and paste, and once one person's got admin, full well that the whole development team is going to get admin pretty quickly. What do you mean I can't apply my own manifests? This is not the way that we've done it before. What do you mean we're going to have to commit everything to Git, and we're going to have to get different teams to be able to approve our pull requests? As well as that, there was a limited understanding of Kubernetes as a tool and a technology inside the engineering department. They weren't Kubernetes gurus, right? And nor should they have to be. So we had to work with them quite extensively on the migration and the rollout and leveraging this platform. So we worked with them on the back-end chart as an example. We took each product team in, we helped them onboard their first couple of microservices, and then we essentially shipped them back to the product teams. And then via osmosis, all of their developers within that team knew how to onboard a Helm release into the cluster. So we did this with all the product teams. And now what we were starting to see is they were deploying applications from a Kubernetes standpoint and from a Terraform standpoint without us even being involved, right? They told us that they needed a new namespace. We created a new namespace, and then we completely got out of their way. We had a blessing and a curse. So obviously we were, Mettle is, a venture that sits inside NatWest. So we have the stability of being backed by a larger organization, right? But they also had the microscope on us, right? Where's your red tape? How are you doing compliance? Where's your audit trail, et cetera, et cetera, et cetera. But now, because we're using Git as the central source of truth, our commits are our audit trail. Our PR merges to master are our audit trail. So we were able to tick off their tick list one by one. It wasn't as easy as that for some things, but we had a nice way of being able to keep them happy. So it was kind of a blessing and a curse. There was a lot of back and forward there about how we were doing things. But a couple of months before I left, we were actually having conversations with NatWest about the way that we were building and leveraging our platforms. And I think via osmosis they're starting to do things and align with some of our patterns and some of the ways that we were and are still doing things at Mettle. This was a big one. So Buzz Lightyear is essentially a product owner or a developer in a product team. At the time that we were building the platform, we were pretty poor at outbound communication of what we were actually building. And then we just one day said, okay, well, now we're ready to deploy. We're ready to onboard all of your applications. And they were like, well, what the hell is this thing? We've never heard of it before. We've never seen it before. So I think one of the challenges there was distilling something that from the outside looks ridiculously complex down to the bare minimum that they need to understand to be able to leverage the platform and innovate for their customers and build better products. Git oops, right? We've leveraged Git ops, but there is also Git oops. Things do go wrong. Git sometimes, especially GitHub, is offline and doesn't work. So we couldn't reconcile new versions of applications into our clusters. And as well as that, from a Kubernetes standpoint, there was a lot of moving components there. There was some Fluxes, there were some Helm operators, there were some still secrets controllers. So writing the documentation there to make sure that every team understood those was a challenge. But once we got it right, they were able to, as we've kind of alluded to before, deploy their own products. So a prime example that I always kind of go back to was a new products team got spun up at Mettle. And within a week, I think it was actually within 2 weeks, they deployed 15 microservices and all the infrastructure that they needed all the way to production without even talking to us, right? And from a platform perspective, that is absolute bliss, right? That is the opposite of the tug of war, and everybody's singing from the same hymn sheet and knows how everything works. So some main takeaways that I want from this presentation, some kind of key points here are that we, from V1 to V2, increased the number of production deployments by 50% and more. The mean time to recovery for our clusters, it was 20 minutes. Before, if you asked me in V1, it was unknown because no one had a clue how it was put together because it was all kind of ClickOps. And I think the most important one is that developers are 75% less focused on operations and more focused on delivering value to our customers and shipping applications. I think the real takeaway is this: the platform's team customers are the developers. If the developers are happy, the platform team are definitely going to be happy. There's clear ownership boundaries there. We make an even awesomer platform and make things more self-service. They get on with their product development and keep the product leads and the product teams happy, right? Everybody wins. So how can you get started? I'm going to kind of leave this on the screen for a second. The top half of this links are some of the tools that we've talked about in this talk. The bottom half is a set of links. So the deprecation policies that we're running for deprecated API versions, a GitOps with Customize, which is a very simplistic repository that kind of demonstrates how you could implement this for one of your product teams. And then I've blogged about this in a lot more technical detail on Medium. So feel free to read those, write comments, reach out to me if you want to discuss things further. And that's all I have. Thank you for having me.
Thanks, Steve. Shall we look at some questions in the chat? I saw there was one from Mike throughout your talk.
Sure, I'll stop sharing and come back.
Yeah.
So Mike said, what was the size of the team? How many developers and operations resources? So the platform team at the time that I joined was myself and another gentleman. And for the large duration of the V2 implementation, to get it to a position whereby everybody had cut over, was 4 of us, including myself. So there was 3 other engineers that were there. In terms of developers, 20, 30, 40 by the time I'd rolled off after kind of 2.5 years. So there was a big imbalance, as you could see, and there was still an imbalance in the V2 implementation as there was in the V1 implementation. But the developers were completely self-service. They could do whatever they needed to do to be able to deliver business value. Adele said, what was the most challenging part of the migration? So I think the most challenging part of the migration was getting everybody on the same page from an understanding standpoint, right? So there was this shared responsibility model, shared ownership model, but there was also, most importantly, a shared support model. So we needed to make sure that all of the product teams understood the components that they needed to deploy changes for their apps, but also understand the grand picture of how everything was put together. That was the kind of most challenging piece. I think it was an understanding of a complex system and distilling it in such a way that all of the product teams, all of the developers, even senior level management understood how this thing worked. What was the most rewarding part of the migration? I think product teams being able to deploy their own applications without us even getting in their way, right? If I go back to when I arrived and this kind of tug of war and the 2 dogs pulling at the rope, and now after this kind of long kind of migration journey, seeing developers flourishing, keeping product owners happy, shipping features to customers, iterating on a ridiculously fast rate, way more than we ever saw in Platform V1, was a great success. And in terms of the most rewarding part for me personally, I left Mettle knowing that it was in a really good place, right? And that, to me, from a professionalism standpoint, is something that I'm extremely proud of, and I'll thank the Mettle team for that. Omar said, how did you make sure that Circle CI was secure enough to control the entire cluster? So Circle CI was only ever doing linting. It was never doing deploying. So if you remember, when we merged to master, the Flux agent inside the cluster is syncing. So from a security standpoint, we had a deploy key that was constructed as part of Terraform for that specific Flux in that specific environment to talk to that specific Git repository. And we had a way of being able to rotate those deploy keys if we needed. So we were in control of the deployments. The thing that we had to secure was that connection that was established from Flux to the repository. Dan said, what's InfoSec's views, thoughts on setting Atlantis endpoint, exposing it to the internet? So from an InfoSec perspective, or just a general concept of how we implemented everything, was that we leveraged SSO in front of all of our endpoints. So you wanted to access Prometheus, you had to log in via our OIDC. You wanted access to Kubernetes, you had to get your kube config via logging into OIDC. So yes, it was a publicly accessible endpoint, but you couldn't see anything unless you got in via SSO. So that made our onboarding and offboarding implementation very easy. We just took them out of the group in our SSO configuration, and they were removed from everything. They couldn't access any Kubernetes clusters. They couldn't access any of our UIs. They couldn't access Atlantis. And because we had something that was under central control, so we owned the Atlantis implementation, the way it was implemented was done by us with kind of strict role-based access control. The Atlantis agent had the ability to be able to assume a very specific role within our accounts, and that role was what was used to deploy Terraform. So if your role in your account didn't allow you to be able to create an S3 bucket, then you wouldn't be able to create an S3 bucket from Atlantis. It was very tightly locked down, and it was so tightly locked down that when product teams required new, they were using brand new tools in Amazon that had never been used before, they had to explicitly create a PR that opened and allowed that IAM role the ability to be able to leverage that resource in Amazon. Have you kept up to date with Flux? And if so, if you were doing it again, would you prefer Flux V1 to Flux V2? Oh, controversial. So yes, I have kept up with Flux V1 and V2, and V2 right now has just got feature parity with V1. There are a lot of moving parts with V2 that, from a bootstrapping perspective, that I myself am actually having conversations with Weave about the simplicity that we managed to get with a V1 implementation, how we can implement that in V2. So there's conversations going on there about the initial bootstrapping of a cluster. The thing that V2 gives you that V1 doesn't is they have hit all of the problems that a lot of people, including myself, discussed with them, which was around observability, knowing when your Helm releases had failed, knowing when you've done an automated upgrade, et cetera, et cetera. So from an observability perspective, yes, V2 is definitely the way to go. From an initial bootstrapping perspective and the way that we were doing it at Mettle when I was there, and the way that I've implemented it again in my new gig, it's not there just yet. So I would still stick with a V1 implementation for right now, for me, the way that we bootstrap the cluster. But if you're okay with doing a few little bits at the beginning manually, V2 is definitely the way to go.
Nice. Thank you, Steve. I know we're on time. I just wanted to say thanks a lot for preparing the talk. It was super, super insightful. And I know a lot of time goes into a half-hour presentation. So really appreciate it. Thanks, Adele and Cara, for organizing. And thank you for everybody for joining us and for spending time tonight with us. And hopefully we'll see you next month, actually on the 27th of April, where we have the Chief Technology and Information Officer of Covia Insurance, talking about how he's disrupting the insurance market with his team. Thank you and good night.
Just so everybody knows, there will be a recording and it will be posted in the LinkedIn.
Yes, and we'll send it in the follow-up email as well, so everybody will get the link. Thank you.
Perfect. Thanks, everyone.